Renewable energy. Indispensable energy in lives. Sustainable Development Goal 12 is to guarantee that consumption and production patterns are sustainable. Promoting resource and energy efficiency is important to sustainable consumption and production. Economic and social advancement, including growth, population increase, urbanization, intensification of agriculture, rising energy usage, and transportation, all endanger our future development and survival-dependent systems. This is called environmental degradation. The environment is under pressure of air pollution, solid waste, water extraction, biodiversity loss, and greenhouse gas emissions to keep up with economic expansion and to meet human needs for material goods. Our manufacturing and consumption patterns must be changed to more environmentally friendly approaches. As a result, renewable energies are preferred to progress environmental sustainability challenges by utilizing the power of endless natural sources that are less detrimental to the environment. Why is it important? It has a lower environmental impact than non-renewable energy resources. Hence, there will be lesser greenhouse emissions and air pollution can be reduced. It is widely available, thus very reliable. Besides that, renewable energies can be constantly replenished, so there is no worry about depletion of these energy sources. Climate change, increased energy consumption, and waste and pollution production are currently the most pressing issues. Chemical engineers' responsibilities include developing alternatives to current processes that drastically reduce or eradicate greenhouse gas emissions while improving resource and energy efficiency. First, chemical engineers use one of the green chemistry principles, design for energy efficiency. Energy requirements for chemical processes should be minimized, using ambient pressure and temperature where possible, to design chemical processes and equipment that produce significantly fewer greenhouse gases. Moreover, chemical engineers are also in charge of making chemical processes more efficient so that large amounts of energy demand can be minimized. These can be done by reducing overall flows of material and/or heat by using reactants or catalysts. Furthermore, chemical engineers operate and manage plants to run on significantly less energy by lowering a building's or processing plant's energy requirement. This can save money by lowering energy costs, extending the life of equipment by reducing loading, reducing running periods and levels of equipment, and even allowing certain equipment to be decommissioned. It also decreases heat generated by equipment or lighting that adds to the HVAC system's load. Besides that, chemical engineers must also think innovatively about how to transition from fossil fuel-based energy to low to zero carbon energy sources, favoring renewable choices, in order to dramatically cut greenhouse gas emissions. Of all problems we confront, excessive food waste is often neglected. Every year, an estimated 1.3 billion tons of food produced become waste. Landfilling produces a lot of methane gas, which is a more potent greenhouse gas than carbon dioxide, thus causes great pollution. Rather than being released into the atmosphere, it can be collected and converted into electricity. This process is called anaerobic digestion. First, food waste is collected and delivered to an anaerobic digestion plant. Before processing, food waste is pre-treated. Food waste is then deposited in an anaerobic digestion container, where it is broken down by natural microbes and process is hastened due to the tank's temperature and conditions. Biogas produced contains 50 to 70% methane, 30 to 40% carbon dioxide, and trace amounts of other gases, where methane gas is collected for energy production. The processed digestate is used as fertilizers, which can reduce the need of chemical fertilizers. Not only can it provide heat and electricity in a renewable energy form, it can decrease food waste, restrict methane emissions and lessen reliance on fossil fuels. Besides that, refined biogas produced is a renewable natural gas (RNG), which can be used to fuel vehicles. According to a waste-to-wheels analysis, RNG reduces greenhouse gas emissions by up to 91% when compared to petroleum gasoline. Study shows that food waste has up to 3 times the energy potential of biosolids, where anaerobic digestion of food waste is comparably efficient. The disadvantage is that the expense of building an anaerobic digestion plant costs a lot. A typical 2 megawatt digester with 40,000 tons of food waste might cost between 19.9 million and 33 million ringgit to build. However, looking at the payback of waste treatment in the future, it is a worthwhile investment. Thanks for watching.